Hi everyone, my name is Karian Limsky and I will be talking about AWS design implementation on financial services. So we are on group 74. So my part is will be talking about storage. It will be covering the simple storage solution, Amazon S3 Glacier, Amazon RDS, MySQL, and DynamoDB. So the first one, Amazon S3 bucket. Here I will create a new bucket. The bucket name, for example, I'll put on finance demonstration, and then the ownership will be the same, recommended, and then I will untick the block up all public access so that I can access the files upon uploading, and then I acknowledge, and then I enable the bucket versioning. There's a server-side encryption, and then I will create the bucket. Next, in this financial demonstration I just created, I will upload a file to it, download, and then I will just upload it, and upload successful. We'll go back to the bucket list, and then for the permission, we need to edit the bucket policy to grant us access. Successfully edited the bucket policy. Now, if we access the file, it should be downloading. Yeah, so you can see the file right now. Next, we will move on to the S3 Glacier. S3 Glacier is inside the Amazon S3 as well. So we need to go back to the bucket, and then on the management, we will update the lifecycle rules. We will need to create the lifecycle rule, and then we name it S3 to Glacier, and then we will apply to all of the subject object in the bucket, and then we will choose the transition non-current version. So the non-current version will be moved to the Glacier, and then the storage class, I will choose the Glacier Instant Retrieval. You have a lot of options down here. You can have a look which one is the most suitable with your organization. And then number of them, put 30, and then I will create the rules. So the rule has been successfully added. Next, we will move to the databases. Here, I will create a new database. I will use the standard creation and then choose MySQL. I will leave it the engine version the same, the template, availability, and then the setting, I will put it finance DB. Then we will create admin, self-manage. Password will be admin123, just for example. Okay. Next, you can also ask for the AWS to auto-generate password for a more stronger password. Next, I will leave it all the same. The VPC, I will choose the existing one and then use the default one. And then the database authentication will be password authentication. And then I will create a database. Since this creation will take a while, I will use this one that I've created to show you example. So here's the connectivity and security. You can see all the configurations inside, and the monitoring is the CloudWatch. You can see this usage balance, CPU credit balance, and the CPU credit usage. Logs and events will give you like what is the system doing, and the events what is doing, and then it's the logs as well, the error logging, running logs. Then I will talk about the DynamoDB. So DynamoDB is the fast and flexible NoSQL database service for any scale. To create, we'll put a table name. I will put, for example, customer table, and I will put customer ID. You can choose from binary, number, or string, and then the sort key, I will put creation date, and then create table. So now the customer 11 table is active. I will try to insert an item. For example, customer ID will be 1001, and then the creation date is 10 2025, and then it will show that 1001 customer ID on the creation date. Thank you very much.
Hi, my name is Daniel and I'll be covering security in the AWS cloud environment. Security methodologies we chose to implement into our solution include data encryption using AWS KMS, meaning key management services, data logging using CloudTrail, monitoring and alerting using CloudWatch, and AWS Shield Standard. I'll be first starting off with AWS KMS. First, we want to search KMS into the search bar and select the first option. This will take us to the KMS console. Then we want to select Customer Managed Keys from the side navigation pane and select Create Key. Symmetric will be the default option for key type. Encryption and decrypt will be the default option for key usage. We'll leave them as they are. And select Next. For the name, we can call it My KMS Key. We'll leave the description since it's optional and select Next. For key administrators, we'll search in the search bar Voke Labs and select the first option. Then click Next. For define key usage permissions, we'll also search Voke Labs and select the first option, just like the previous step. We'll click Next and Next again. Here we can review the key configurations we've just made to the KMS key. Once they're correct, you can scroll to the bottom and select Finish. We have just successfully created an AWS KMS key. Next, I'll be covering data logging using CloudTrail and monitoring and alerting using CloudWatch. So here, first we'll search CloudTrail and click on the first option. This will take us to the CloudTrail console. Here we'll click Create Trail. For trail name, we can call it My Cloud Trail. And for storage location, we'll select Create New S3 Bucket. We'll disable log file encryption, so uncheck the checkbox. Next, it is important to enable CloudWatch logs. For log group, we'll leave it as new, and for IAM role, we'll change it to existing. In the drop-down box for role name, we'll select this one and click Next. Here, for events, we'll select Management Events. For management events, we'll select Read and Write for API activity. Once that is selected, click Next. Here we can review the configurations we've just made to the CloudTrail. Once they are correct, you can click Create Trail. Once you've done this, you have successfully created a CloudTrail with CloudWatch logs enabled. Finally, AWS Shield Standard. AWS Shield Standard is a protection service that is integrated into the AWS cloud environment. This built-in security measure has the primary purpose of defending cloud applications from network, transport layer, and distributed denial of service attacks. This service is enabled by default on all AWS accounts and requires no setup process. In the event of an attack is detected, AWS Shield Standard automatically filters malicious traffic on the network to ensure cloud applications stay operational. That is the end of my section. Thank you for watching.
Hello guys, I'm Amar. So for the network protection part, we will talk about the network configuration for the VPC. So it shows how we're going to protect that. So we have the subnet settings, internet gateways, route tables, NAT gateways, and the ENICL, security groups, and ALBs. So this is our plane at the right side. So here it is. So we have our VPC here with the CIDR /16. So actually we can see the resource map here, what we have done. And then we can see the subnets. So since we have two availability zones, so one each for public and private. So this public subnet one for US is 1A, and private subnet one also for US is 1A. Yeah. So for the public and privates too, we use US is 1B for each of them. So at these configurations, we can actually see our configurations for the other part, but let's get to the internet gateways first. So we made internet gateway. This is for the VPC to connect the internet. Got the VPC attached here for this internet gateway. And then we set up the root tables. We set up for the public root tables and private for each region. So it is associated with two subnets, which we have the public one and public two. And then for the private for each one. So this is the roots for this. And then that's for the NAT gateways. So we create NAT gateway for each availability zone. And then we've got the network ACLs here. So saying we setting up for the public and private for the inbound rules that we needed for the applications, for the financial applications. This is network ACLs on the subnet level security. For the rules, the level of rules for each subnets. So we can see here we associated this one's for private subnets and this one's for public subnets. For the private, we set some rules for MySQL also. And then for the security groups, for the next one, we have the main, just one security group here to allow HTTPS access and SSH. And then after that, we can go to the application load balancer. So for this, we made target group and autoscaling group for this. So you can see here the rules, and currently this one is HTTP only since we don't have the TLS certificate, but in the real world we should put the TLS certificate here. So we can use the HTTPS. Okay, thank you. That's it for me.
Hello everyone, my name is Owen Franklin. My student ICC is 2573162. Now I'm going to demonstrate about the identity access management, also known as IAM, in cloud security design. So what IAM protects is identities, roles, risk privilege, and workload access. So our choices in this assignment is IAM roles, permission boundaries, ABAC, MFA, access analyzer, keys version, and it gates every control plane data or data plane calls. It also feeds audit or IR via CloudTrail and Security Hub. So I'm going to show the implementation from task 2, ABAC with department equals to finance, permission boundary to cap privilege growth, and workload role. Then I'll validate with the policy simulator and access analyzer. So in the console, it is currently logged in as a dev user. So I'm going to switch role. Copy your account ID first. It's 9500516570550. And I am role name is break glass admin. And press switch. I assume an admin role with MFA is short-lived and auditable. So the KMS alias finance data, I think I've created before. It's already pre-created. As you can see here, there's a finance data, and there's the S3 finance role. It should be stored here as well. Yeah, finance role AF. AF is my initial, Ivan Franklin. I'm going to build create a ABAC policy. So starting from IAM policies, create policies, and there's I've created the JSON file. So I just need to paste and press next. Person name Paul Finance role with ABAC. So it only allows only list or get on one prefix if the principal has department equals to finance. That's ABAC. So just create a policy. Yeah, it's been created, and now I will be creating the permission boundaries. So I go to IAM policies, create policies, JSON. I have the copied file as well, so just need to paste. And next, PB non prod max. So this caps what the role can ever do, even if someone tries to add more policies later. So also I'm going to create an app role attach boundary tag. So IAM roles, create role, AWS service, and should be using EC2. Then next, attach the Paul finance role, which we just created before. Next, set the permission boundary. I think this one is just the role. The role name is app finance. App finance reader. Permission boundary has been added, and create role. Yep, it's been successful. The result is list. So basically, result is list privilege via IBUG, permission boundaries to prevent privilege creep, roles of users, and evidence via access analyzer plus CloudTrail. So this is the end of my presentation. Thank you so much.